Okay, I'm guessing you're going to have a problem with this one because it's a little weird because what we have is a brick being pushed against a vertical wall. So it switches the usual direction of friction. So let's say this is the brick, there we are, and we're pushing horizontally. So there's the force of our push here. We know that the weight of the brick is down this way as usual. That's the earth pulling on it. So if we look in the vertical direction here, what the heck is holding this thing up? Why is it not in free fall? And the answer is, well, there must be a frictional force this way from the wall. So the frictional force is that way, which is unusual because it's up rather than at right angles with gravity. So we have a 1 kilogram brick, and they tell us the coefficient of friction static and the coefficient of friction kinetic, and then I want to know what is the acceleration of the brick. So to decide that, we need to know whether mu s or mu k, first of all, is mu s, is the force of static friction going to be big enough if this happens to be static or kinetic? That's what we need to know. Is static big enough to hold it up? If it's not, it's going to budge, and when it budges, we're going to fall from static friction to kinetic friction, which is always less. So what we need to do is the usual procedure here. We need to identify all of our forces. So let's say that up is positive and to the right is positive. Let's assign our directions. And let's do a net force equation horizontally. Well, we have one more force here. We're not accelerating to the right, so there must be another force pushing that way, and that's the wall. So the force normal is now to the left instead of up like it usually is. So in the x direction, the net force in the x direction is going to be Fp minus Fn. We already know this is going to be 0 because we're not accelerating that way. There is no net force, right or left. So that will just simply tell us that the push is going to be equal to the normal force from the wall. That's going to be important when we calculate friction later. Okay? How about in the y direction? In the y direction, what we know is the net force in the y direction is going to be force of friction is actually up minus my weight, which is down. All right? And again, this may or may not be 0. So we'll go ahead and just safely put in, okay, net force is ma. That is going to equal the force of friction, and the equation for force of friction is force normal times mu. We'll not decide yet whether it's static or kinetic, but let's just guess that it's static and hope that it holds. Minus mg. Like that. All right, so we know that this is 24 newtons here, which tells us the force normal is also 24 newtons. So we can put in 24 newtons here, and they tell us the coefficient of static friction is 0.8. Okay? They tell us the mass is 1 kilogram. Okay? And then that allows us to know that the weight is going to be this. So here's what we need to do. We need to decide if the right-hand side of the equation is positive or negative. Because if it's positive, if it's negative, it's going to accelerate down. So we need to use our calculator here. Use our calculator and calculate this. Comes out to 19.2 newtons minus 9.8 newtons is going to equal the net force. Well, that comes out positive, folks. And since we said up is positive, what that's basically telling us is this force of friction, this is the force of static friction, right? This is the weight downward. Well, the weight downward is not big enough to equal the maximum force of static friction, right? So even though it looks like this is a net force that's positive, we know it's not going to. We know that static friction is not going to make me accelerate up the wall. So what's going to happen is nothing. We will get no acceleration. Even though it appears to be a positive net force upward, we know that's not going to happen. All this is telling us is that this can get bigger and bigger and bigger. That weight can be bigger and bigger, and it has to be 19.2 for anything to happen. It would have to be 20 or something like that to accelerate down. So the acceleration we know is just going to be 0. Static friction is more than enough to hold weight.